This video will be a continuation of a tutorial on Simulink data type propagation engine. In particular, we'll be covering the second half of propagation time when a block receives a proposed data type. As we showed in the previous video, the first step was that the block either accepts the data type or throws an error. If it didn't throw an error, it can go to step 2. And in that case, the block will use any inheritance rules that are specific to that type of block and to the instance. For example, there can be parameters that control the inheritance rule that is in effect for an instance. And using those inheritance rules, the block should set as many unknown port data types as it possibly can. For example, the unit delay's data input port must use the same data type as its data output. And so once it knows what its input data type is, it should immediately set its output data type to that same type, and vice versa. Okay, let's go and show an example. So I've set up a model here where we have this block which is setting the output to single. We have another block that is passive about its data type initially, but once it knows its data type, it's going to set the other data type, port data type, to the opposite, where opposite being double versus single. Similar thing is happening over here. Here this block will set its input data type to single, and then Simulink will propagate that backwards to this block. So sometimes we talk about the direction of propagation. In this one, this is a known type, so the data type is propagating forward, passes through the block, and will propagate to here. In the second row, it's known here, this propagates backwards to this block, and then that propagates backwards to its input port. And that propagation will also continue on to the terminator and the ground. Okay, so let's go ahead and do that. And I've set up a C++ debugger, and I'm stopped in the initialization phase for that first block, which is setting its input port data type to single. And let me go ahead and set up this block as well for its initialization phase. Okay, so this one is explicitly setting it to single. Now if I continue, now we're coming to this block, one of the instances of this block, and this is going to set its input port to inherited, also known as dynamically typed. So it doesn't know yet. And then it's going to set its output port also to inherited. And then we're done with that. And now it's coming to this out single, which only has an out port, and it's going to set that to single. And now we're in the second instance of this reverse double single block, and it'll set things to dynamically typed. So if we continue that, now we're coming into one of the propagation methods, model set output port data type. So again, Simulink engine is taking information that it knows from other blocks and propagating it into this particular instance of this block. So this is the one where the downstream data type was known and the information is propagating backwards. So it's proposed that the first input port have data type index 1, which is single. So first it's going to do the accept or reject action, and it's going to check it and says, yes, this was single, so I accept it. So it will do the acceptance, and now it's going to go into its propagation phase, and it's going to set the other data type to the opposite of what came in. So now the other is going to be 0, which is data type double, because single was what came in. And then it'll set its input port to that data type, and then it's done, and that information has been passed on to Simulink engine, which will then further check the information for consistency and further propagate it to other blocks if there's no error. Okay, Now we've come to the second instance of this reverse double and single block. Now it's a forward propagation situation. Another block has set the input port, the data type of this block's import, and so the first input port has a proposed data type of 1, which is single, and that's one of the accepted data types of this block. So it accepts it, and then it propagates as much as it can, which in this case it knows its other port should be the opposite. So it will set that, and then it lets Simulink engine continue, and we get to a happy state of update diagram succeeded. We can view the diagnostics with these S functions are printing out a lot of information that we can then use to walk through our exercise of pretending to be Simulink engine. So first B11 came and said, I must be a single. Then we had B5 was inherited, B6 said it must be a single as well. Okay, so we have that information. B9 said both import and output to inherited. And that completed, as did B5, that completed the propagation phase, I'm sorry, the initialization phase. The ground block and the terminator block were also involved, but those are not instrumented with these little printf methods. But they also, as they always do, said that their data types are inherited. Okay, so next we went into the propagation phase, and we called Simulink engine called B9 and B9 and said, hey, do you accept your output port to be single? So B9 is that doesn't seem right. I'm confused here. Give me a moment to look at this. When I said, oh, I'm sorry, B9 is in here twice, so that was my mistake. So B9 has an output and B9 has an input. So as you should have expected, this was a known data type, so and this all corresponds to this signal D, so that's where the propagation can happen right now. This is the information Simulink engine is able to propagate. Either signal D or signal A is all it can propagate at this point. So now it came and it said, do you accept single? And the block said, yes, I do accept single. And the block also went to the second phase and said, in addition, I can tell you that my input port is also a single. So that's where the other side of B9 gets set. So now we've got a happy state here, and now Simulink engine has additional information that it can use propagate. So it could go to that terminator and say, hey, it's proposed that you have a single. The terminator block will accept any data type, so we know there'll be no problem there. And so that can get the single, and that will be happy. So next it will go to B5, and it will say to B5. Okay, I put that in the wrong place there. Let me correct that. Terminator and ground are both very accommodating blocks. So now we have the known information. Simulink engine is propagating this single to this block and says, hey, do you accept single? And so B5 says, yes, for my input port, I will happily accept single. And so that's all set. But then it goes to step 2 and it says, hey, by the way, I also know that my output port should be double. Okay, and it looks like I messed that up before. So I messed this up when I did this propagation before. B9 was setting its input port. It should have been setting that to a double. And that got propagated to the ground. which is a double, and the ground was happy with a double. Okay, sorry about that mistake. And likewise, finally, Simulink engine knows this now, and we'll propagate that to the terminator. And again, terminator is super friendly, so everybody's happy. Everybody connected to A agrees it's a single. Everybody connected to B agrees it's a double, and so forth. And internal to the blocks were all happy to receive the data types that were proposed. So we got to a happy situation in this update diagram. Okay, so this video has shown step 2 of the propagation time, where a block receives a proposed data type. If it accepts it, it then looks at its inheritance rules that are known only internal to the block. Simulink engine doesn't know about those. These are inside the block. But the block has the responsibility at this point to set as many other data types as it possibly can. Once it knows what another data type must be, it should go and set that information and then allow Simulink engine to check it and propagate that further to other blocks.